Hi, everybody. Welcome to another HOSS Talks FOSS. I'm the HOSS, Matt Yugabyte, head of open source strategy here at Percona. Today, I'm joined by Denis Magda from Yugabyte. Denis, how you doing?
Feel great. Feel all right. How are you doing, mate?
Good. Now, Denis, I don't know if you knew this, but we actually worked at the same company at the same time.
No, serious. I'm serious.
Serious. So Denis doesn't know this, but I did look up his background, and while he was at Sun Microsystems, I was at Sun Microsystems.
Wow.
So I was actually on the MySQL team when we got acquired, and then was with Sun up until the Oracle acquisition, and then I left for Percona.
Wow. Okay, with your ex-colleagues, excellent.
And we didn't even know it.
No, I think that we have never met during the Sun days, because I met with some of their ex-MySQL folks. Those days I used to live in Russia. We had Sun used to have a development center in Russia. And many guys from the MySQL team usually would come to that office. We would kind of have nice conversations, etc. But great to know that we were colleagues.
Who knew, right? So, I wanted to maybe talk a little bit about, what you're doing now is you're in charge of DevRel at Yugabyte. You're in charge of the community outreach and getting people to, get excited and educated on what Yugabyte can do. But you didn't start in the database space. You started in Java. Maybe tell us a little bit about what brought you to databases eventually and how that evolution worked.
Yeah, the story, like my professional career is a little bit different. I started at Sun and at Oracle. Those days I was on one of the Java development teams. We basically, if you guys remember Java Micro Edition or Java Embedded, I was on the team. We were developing JVM and JDK for different mobile phones and embedded devices. So generally, that was my team. Why I joined Oracle, why I decided to develop Java, because I was always curious about the internals. Before joining Oracle and Sun, I was a professional Java developer. I used to create different backend applications, web applications, etc. I played with mobile applications, but I always wanted to look inside. I was curious, like what Java engineers do to make Java working on different, let's say, operating systems. And eventually, I was lucky enough, I passed an interview, I joined the development team, and after that, I barely wrote code in Java, because when you're working on the porting team, you literally take in the JDK and JVM, and you use C, C# or even assembly language to make sure that your JVM works on different microcontrollers and mobile devices. I was happy.
Okay.
Yeah, I was happy. However, while I was on that team, you know that like in Java, we can create multiple threads, and those threads can execute different tasks in parallel using your like CPU, etc. The thing with the Java Micro Edition is that regardless of how many threads on the Java level you create, those threads will be mapped to a single operating system thread. So generally, like you are not creating highly concurrent applications with mobile phones. It's like using Java Micro Edition, because probably it didn't make any sense. But I was studying during my free time, I was studying Java concurrency. I was just trying to create highly concurrent applications. And then when I decided to switch gears, I looked for different companies who were using Java, who were creating, let's say, some cutting edge technologies. And the companies who was with an open source spirit. And that's how I came across GridGain. GridGain is one of the companies that donated Apache Ignite to the Apache Software Foundation, and they remain still one of the major contributors to the project and to the community. So Apache Ignite, for those who don't know, it's a distributed database for high-performance computing and memory. So that's what they do. And I joined this company, I joined GridGain, and I joined the Apache Ignite community as a senior software engineer. I was contributing to the source code of Apache Ignite, to the networking layer, to the storage layer for more than half a year. But then company and I myself, we decided I want to be like on the field. I want to talk to the users. I want to talk to the developers.
Yeah.
Talk to the customers. And that's basically what I used to do at Sun when I was on the I belong to the so-called Sun Campus Ambassador Program. It's when I was one of the Sun Campus Ambassadors evangelist at my university. I was helping developers and graduates to learn Java and other Sun technologies. And that's something that I started to realize at GridGain. And that's why I joined, let's say, I tasted and tried many roles at that company. I was in the support team. I was on the customer, on the professional services team, and eventually then I was leading the product management and marketing. However, my last 2-3 years, I was leading the developer relations for GridGain and for Apache Ignite. Throughout like last 5, 6, 7 years, became one of the top 5 projects of the Apache Software Foundation. I like this community. I love these guys. I wish them luck, but eventually, I sensed that I need to move forward. I want to explore something else. I wanted to remain within, let's say, the database area, and that's how I came across Yugabyte. So right now I am with Yugabyte. That's my 3rd month in a row. So I'm really new.
Yeah, new.
Yep. But I'm excited. I mean, like, we have a lot of things to do here, and I think that developers, and after I joined the company, I see that developers truly can benefit from distributed databases such as Yugabyte. But Yugabyte is not the only one, right? And that's good because you always have to have a competition in the market. Only this way you can, let's say, innovate faster, and you can listen to your developers, to your users. So that's my quick story, how I ended up from a Java engineer and Java engineer turned head of in a database company.
Yes. No. And I mean, it's an interesting journey because, I mean, obviously Apache Ignite's database, it's just a different type of database than Postgres. So it's a little bit different to get used to. And so I'm sure that was a bit of a switch. But I mean, relational databases have been around for so long. It's not that difficult to make that kind of migration from where you were. Now, I am curious, for those who are listening, many people might not have heard about what distributed SQL is. I know what it is, but maybe you could just give an overview of distributed SQL for us, just for those listeners who might be new to this space.
Yeah, sure. That's probably the best question to start with, right? If you want to talk about distributed SQL databases. So my explanation is quite straightforward. All of us, we like, if you have ever created any like web application or mobile, at least a web application, enterprise application, you usually, it's the chances are high that you use the relational database. It could be Postgres, it could be Oracle, MySQL, IBM DB2, or any other. And you usually use what? You use SQL statements, you use joins, you use stored procedures, you use different triggers, because that's how we historically were introducing different functionality and how we kind of requested and processed data that resided in our databases. And when it comes to the distributed SQL, the concept is simple. So you still have the same SQL, the same joins, the same stored procedures, the same triggers, the same transactions with the same isolation levels, but right now you want them to work at a global scale. And when we're talking about the global scale, if you take an example of a standard single server relational database, we can take Postgres as an example. It usually runs on one instance, right? On one virtual machine, on one physical server. And your application, once the application connects to this server, it can start like issuing SQL requests, trigger different stored procedures, etc. But when we are talking about distributed SQL, you also have your relational database, but right now it spans across multiple nodes. You can have 5-node cluster, you can have 10-node cluster, 15-node clusters. Those nodes can reside, if we're talking about the cloud, they can reside in the same, let's say, availability zone or in the same region. All those nodes can spread across multiple regions if you want to survive, let's say, different outages. But regardless of that, regardless of the deployment mode of your database, for the application, the experience remains the same. The application still usually connects with a single endpoint. Even if you have, let's say, 10 or 50 nodes cluster, your application still connects to this cluster with one IP address. And then the magic happens on the database layer. Your application keeps sending the same SQL statements, the same joins, the same transactions. But right now, if you execute any transaction and that transaction spans multiple nodes, then the database is responsible for the consistency, atomicity, and other characteristics of the transactional processing. So generally speaking, to make things short, distributed SQL is the same SQL you're familiar with, and there are many dialects. You might be dealing with, let's say, distributed database that just supports like it's ANSI 99 or ANSI 2011 compliant, or you can be dealing with a database that is that wants to be compliant with Postgres dialect or MySQL dialect. But eventually, from the application developer standpoint, it's the same SQL, right? You execute them, and ideally, most of the queries and most of the features should work out of the box.
Now, a little bit deeper into that, one of the big things, though, is architecturally, it is different than standard Postgres or even other clusters because it's more reliant on sharding in the backend, correct? Like so data it's not a share everything, right? Because everything's not on every node. So, there are clustered systems or replicas that you can build that will have a copy of every database on every one. But when you're talking about when you have 15 node cluster, each of those nodes in the cluster contains a portion of the data, correct?
Correct.
Yeah. So yeah. It's more akin to a MongoDB type architecture in the back end than it is to like MySQL's clustering, their InnoDB cluster or a Galera cluster in MySQL or things like that. And I guess it follows a similar pattern to Citus. In that regard, does it?
Yeah, exactly. There are a lot of similarities, even though there are also differences. If to compare, we like during my session, we can discuss what the difference between different databases. But generally, you're right. When we are talking about a distributed database, usually the data is partitioned. You mentioned MongoDB. Cassandra is also a good example, but from the NoSQL space. Yugabyte and CockroachDB, they also shard your data, or like partition. We use the term partitioning. It's when, let's say, you have 10 nodes in your cluster and you have 1 million records. And then the partitioning algorithm makes sure that all those 1 million records are spread uniformly across the cluster. So like each node ideally keeps this like 200, like 20,000 records and that 20,000, etc., etc. So that's what happens. But also some of we have, and generally like when you partition or shard the data this way, you also need to have the query layer, the layer that receives your requests, and then that query layer knows how to like what node is responsible. What node should be involved in the processing of your query. In case of, let's say, when it comes to, for instance, Apache Ignite, right? Because Apache Ignite, same as Yugabyte, or same as Cassandra, MongoDB, and Apache Ignite, it also shards or partitions data across a cluster of machines. However, when you, let's say, execute a SQL query with Apache Ignite, this SQL query will be like sent to all of your kind of nodes, because on every node, you have a single process. Basically, that process is your storage plus your processing layer. In Yugabyte, the architecture is a little bit different. We have two different processes. We have so-called tablet server. That's a process that's your data storage. That's where your data resides, and that's it's sort of a container for your data processing. But on top of it, we have the query layer, and it's also highly scalable. It's resilient, etc. We call it the master process. You have replicas of that master, and actually the master usually is aware of the data distribution in your cluster. It executes, whenever you execute any DDL statements, all the requests go through that master. But when you start using your Yugabyte DB cluster, like inserts, selects, deletes, then usually your queries will start going directly to your tablet servers, like to your tablet processes. Because those can cache data, they know how the data is distributed. There are some caching algorithms involved in regards to the data distribution.
Yeah, you mentioned, the similarities or, some of the backgrounds with Cassandra, which is funny because the CTO at Yugabyte was one of the original creators of that project when he was at Facebook, right? So Karthik, who's been on our podcast here as well, and talked a little bit about the good old days there. That makes a lot of sense, that there would be some similarities. Now I'm curious, is distributed SQL for every application? Is it something that is overkill in your opinion on some applications, or is it something that you could start with and then ease into kind of that larger scale setup? Because distributed SQL tends to be really good at mass scale, but a lot of people might start with just a standard Postgres and do that migration. So I'm curious your take on that.
So here is a recommendation of Google. They have Google Spanner, which is a distributed SQL database, and also they have other different Google SQL Cloud offerings when they run services for MySQL, Postgres, etc. And their recommendation is this, guys. Usually you use Google Spanner when you need scale, and they usually judge by the amount of data you need. Let's say if you need, global resiliency, if you need to comply with data residency requirements so that your database instance keeps European citizens' data in Europe and never writes this data to America, then you use Google Spanner, or if you need to keep petabytes of data. In other cases, probably explore our Cloud SQL first. And my recommendation, when it comes, let's say, to PostgreSQL, vanilla Postgres, or to Yugabyte DB or any other Postgres compliant database, just do your homework. Do you really need this scale right now? But also think, when you're thinking about now, you have to think about the future. What happens with your application? What happens with your team? What happens with your department, let's say, in a year from now, in 2 years from now? For instance, if you expect that your application has to work across global scale, if your application will be having customers in Asia, in Australia, in Europe, and it's inevitable that at some point in time you would need to have, let's say, multiple Postgres instances, or you need to arrange different Postgres sharding techniques on your own. And at this point, probably you need to start with a distributed database, but that first deployment can be small. So generally, first recommendation, remain with Postgres if all the data that will fit into a single server machine, and you do not expect that, let's say, you would have a much bigger load, you would need any much bigger capacity in the next, let's say, 5+ years. But in other cases, let's say, even if you think that right now everything can fit nicely in Postgres, but in 2, 3, 5 years, you will be running across the globe, or you will be having much bigger load, etc., then probably start with a distributed SQL database, or like Amazon Aurora, which basically another kind of way of transitioning from standard relational databases, because they have a single write, right? Like all the writes go to one node, and you cannot basically scale beyond the capacity of that node, but at least you have read replicas, and those read replicas will help you to remain resilient, and they can be deployed in different regions closer to your customers. So that's my thinking.
Okay. Well, and so those who are listening, Dennis, you alluded to something, but we didn't talk about it, which is you said, I'll be discussing this during my talk. So yes, Dennis is going to be at Percona Live. He's going to be talking about the SQL compatibility between different databases in the distributed SQL space. And it's interesting. I don't consider Aurora distributed SQL. I mean, that's just me. I think it's outside. I think Yugabyte, Cockroach, Spanner are different architecture than Aurora is, personally. But you mentioned the word compatible, and this is what's going to be kind of interesting: is the compatibility of each of the different databases that are out there. It varies, right? So like some might have 60% compatibility, some might have 99% compatibility, but it's going to vary depending on the implementation, and there are some things that may or may not work. And I think that's one thing that is interesting, and it should be a really good talk, and I'm looking forward to kind of listening in on that to see where that is as you kind of go through that ecosystem and talk about the nuances. Sometimes it doesn't matter because it could be, most of the normal features are used, and so nobody uses these really edge cases. Sometimes it does.
Yeah. Speaking about Amazon Aurora, we are on the same page here. Amazon Aurora is scalable. It's just, a scalable solution for Postgres, but it's not a distributed database. At least also in my thinking, just my personal opinion. Forgive me, Amazon folks, if you disagree. Just because, let's say, it's a great solution if you need to scale your reads and you want to tolerate different region level outages. That's what Amazon Aurora is designed for. But it does not design for if you need to outgrow your single server capacity. For instance, let's say your master node that accepts writes is capable of keeping only 30 terabytes of data, but you need 50 terabytes. And if Amazon is not able to provide this machine, you don't have a choice. Yes, yeah, that's the thing. Talking about the compatibility, that's one kind of first kind of reminder. There is the only 100% compatible database with Postgres is Postgres.
Yes.
All the other vendors, all the other databases, some of them are trying harder to achieve a higher compatibility level. But when I will be talking about compatibility, Postgres compatibility, I will be using the language of high compatible, lower compatible, etc. But remember, the only 100% compatible database is Postgres itself. And we will be discussed. You're right. You cannot just select one criteria and judge by that criteria all the databases. It's unfair, and we don't want to diminish companies who I work for Yugabyte, right? But I want to be authentic. I don't want to disguise folks. I don't want to diminish competing technologies. We will be using 4 different features or criteria. The first one is wire compatibility. It's when can I connect to this Postgres compliant database, let's say with pgadmin or any other tool, and execute some commands that I've been using for ages. For instance, I want to connect, let's say, to Google Spanner, and I want to see the structure of my database, the schema, the tables, indexes, etc. And that's the wire compatibility, just the ability to connect and use the Postgres networking protocol. It's all about, let's say, ability to deserialize messages, network packages that are serialized and according to the Postgres networking layer. That's the wire compatibility. The next one is syntax compatibility. I have an application, and this application is designed to work with Postgres. I heavily use Postgres syntax. After connecting to your Postgres compliant database, which is wire compliant, for instance, will I be able to use the same Postgres syntax? Or I have to switch, let's say, to another SQL version of your database? That also matters a lot. And that helps. And that if you try hard to support at least the PostgreSQL, then many of your application developers can be successful during, let's say, the lift and shift exercise. I have an application. I want to move this application to Postgres. The third one is feature compatibility. You have wire, you have compatibility, you have syntax compatibility, but what's about features? Because Postgres, one of the reasons why Postgres is gaining so much popularity these years is it's one of the most feature-rich open source relational databases. They have certainly some basic stuff like stored procedures, materialized views, triggers, etc. But also, unlike other databases, I cannot speak for other databases, but they support features that usually do not exist in every relational database, like JSON, like full text search, like time series, and other some document-based queries. That's what Postgres has. And you have, let's say, an army of application developers who used all those features, probably not HOSS, and they want to move. And then your Postgres compliant database will be judged by this criteria. How are you feature compatible with Postgres?
Are you considering feature compatibility with extensions, or is extensions separate from that? Because sometimes features are considered, synonymous with extensions. Sometimes they're not. Postgres has a really rich extension ecosystem, but they're not part of the core Postgres, right? So it's a little fuzzy.
Yeah, that's the fair question. I mean, extensions also have to be included. I mean, even when I'm talking about Yugabyte, right, as a Yugabyte employee, we are not 100% compatible with Postgres, right? Obviously, we are not Postgres, but we are reusing Postgres source code as much as we can. And but when it comes, let's say, we are reusing the Postgres query layer, but our storage layer is different. We use different storage technology. That's why when you're talking about about extensions that were created for the query layer and not for the storage layer, that is highly likely that they will work without any issues in Yugabyte. But if you created any extension for the Postgres storage layer, then it's highly likely that it will not fly on Yugabyte DB because our storage architecture is different.
Yeah.
And
what was the fourth one?
Final one is runtime compatibility. Is what actually does your application behave similar to Postgres, like how your query executes, what's the write path or read path for your query? Do we use, let's say, what's your planner, what's your optimizer, what's your executor? And generally, that's probably the hardest test because once it's usually if you have a high level compatibility for the syntax and features of Postgres, then the lift and shift exercise should be smooth. You just take your application and you just change the connection endpoint, you connect it to another database, and you can use Postgres drivers. That's one of the biggest benefits if you're compatible, if you have a wire syntax and feature compatibility. Use the drivers and you are good to go. You don't need to create your own bicycle. But the runtime is like how you're going to be tested in production. Because like if your queries, some of the queries start to fail, some of the indexes don't work as expected, etc., then it also happens.
Yeah. No, it's interesting because Postgres is becoming such a kind of the base ingredient for so many new databases, right? It's so interesting because people are approaching this slightly different. So Yugabyte, for instance, you took the client side and kept it and then replaced the backend so you could do the distributed. But I know I just heard, I was at Postgres Silicon Valley last week. EdgeDB was talking about their stuff where they're putting basically like a GraphQL interface over the top of Postgres and doing some things there. I know FerretDB is building a MongoDB compatibility layer on top of the storage for Postgres. So you've got like lots of different people starting with Postgres and then extending Postgres to do things that are really cool and innovative. But Postgres seems to be kind of that seed, component that people are starting to build around, which is really cool, especially if you already know Postgres. It makes it easier to start to get involved and jump into these different technologies. But it is such a solid, awesome core that it makes it easier for people to develop those cool things.
I also had a similar question when I decided to join Yugabyte and start working actively with the Postgres community and Postgres developers. Because I always heard that, like, someone told me, like, I was watching one of the representations of Yugabyte professionals, and they were showing, let's say, that accelerated rise and growth of Postgres. If you go to the DB Engines website that we usually go just to see, like, what are the top most popular databases, Postgres is in the top 5 list, not in the top first, but his growth is probably one of the fastest. And I was thinking, like, why this happened? And then I checked the other, let's say, top 4 databases, so like top 6. We had Oracle, we had MySQL, we have SQL Server by Microsoft, etc. And what struck with me is it sounds like Postgres is Linux of the relational databases. Linux is one of the operating systems that is governed by a true open source community. That open source community is not under control of any other specific vendor. You have the Linux core, right? But out of that Linux core, we have different Linux distributions. We have Ubuntu, CentOS, Red Hat, etc., etc. But the core doesn't belong to anybody. Even if you, let's say, Red Hat or any other company want to introduce something to Linux core, you will be dealing directly with community, and community can pull you down. And I think the same happened with Postgres. We know that, unfortunately, like MySQL still, even though that's an open source database, it's governed like by Oracle. We have Oracle database, we have IBM DB2, etc. All those databases belong to some vendors. But Postgres is an open source driven project. And I joined also the Silicon Valley's conference. I think we missed each other a week ago. And I was on one of the sessions where a Postgres veteran was talking about, let's say, some situations. Some companies, like big companies, small companies, they want to introduce some feature to the Postgres, but usually the community says, first, you need to come and talk to us using our protocols. You need to use our channels. Some people, just are not happy that the Postgres community uses, let's say, some dinosaur-style mailing lists. So, I don't know what was that. But that's the way they interact, because that's quite similar to the Apache Software Foundation. I heard a lot like, hey, guys at Apache, why don't you use, let's say, Slack? Why don't you use that? Why do you use this old-fashioned mailing list? That's how things work, because our contributors sit around the world, and they cannot answer everything instantaneously. Another thing is that whenever I want, probably someone introduced a feature into Postgres or like Apache Ignite. And only, let's say, a year ago, I want to go back to the discussion and I want to see what happened, like how a conversation in the community led to this decision. And that's extremely easy to do with mailing lists. And that helps, let's say, just to balance the speed of innovation and quality of the product. And also kind of push back vendors who are too aggressive, who want to come and take control of the community. And luckily, what I see, that did not happen with Linux. And as far as I understand, it didn't happen to Postgres. That's why with Postgres, I think we have this proliferated growth, and we have so many companies, big companies, enterprise vendors introducing new products, new solutions that reuse Postgres as a core. We have Amazon Aurora, Google Spanner. It's like in October last year, in 2021, then they announced that they are supporting Postgres dialect, and that's a big signal. Even Google recognizes this. So that's my thinking. I think that Postgres became the Linux of relational databases, thanks to its true open source community, the policies, the governance, etc.
Yeah, no, that's an interesting take. And with that, we're running out of time here. So I wanted to thank you for coming on today, chatting with us, giving us a little preview of your talk, talking about your background, and giving us some information on Yugabyte and where it fits into the ecosystem. It's been great chatting with you today.
Thanks, man. It was a pleasant conversation.
And for those listening, we would love it if you come out to Percona Live and see us out there. Dennis will be there. He'll be giving a talk. It is May 16th through 18th, and you can see it there. We'll also have some sessions online. There'll be some things that show up after the session or after the conference as well. But if you do like this kind of content, please make sure you subscribe, like to the YouTube channel, subscribe on your favorite podcast app, and let us know. Put comments in the comment section of your favorite app and let us know what we can do, who we can bring on, who we should talk to, what topics we should cover. We're always interested in what you have to say. Until next time, this is Matt. We'll see you then.
Thanks. Bye-bye. Don't forget to subscribe.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.